right, our last quick lesson is on surface area of pyramids, just like in Egypt. So let's look what a pyramid really means. Yeah, it can mean that it has different kinds of bases, but it will never have parallel sides. So as you can see, the first one has a square as the base. The second one has an equilateral triangle at the base, and the last one has an octagon as the base. What's true about all of these figures, all the ones that we're going to be doing, is that the base always has equal sides. So let me give you an example here. If this is a 3, this will be a 3, this will be a 3, this will be a 3. If this is a 4, this will be a 4, this will be a 4. If this is a 2, this will be a 2, 2. Now, is it possible to have other options? Of course there is, but for our lesson, we're dealing with the easiest bases possible where all sides of the base are identical. So that's the good part. Now, the octagon is just kind of a challenge problem. That's there's a little addendum that we'll have you work on later, which has some other shapes. But basically, it's these first two. Either the base is a square or the base is an equilateral triangle. So let's do something with it. So here we have two of them. And I am going to give you the challenge because this is identical to what we did in the last lesson. But this time, the difference is we have actually less faces to deal with. So in this first one, let's just review it, make sure that you understand what it is. We have a base, and you'll notice that we have said that this triangle at the base is going to be equilateral. So if one side says it's 7, then all of them are 7. So that means this is 7, and back here, this is 7. So there's my triangle. However, it doesn't much matter that there are 7 because I'm not looking for the perimeter. I'm looking for the area of that triangle. So we need to know the distance across the triangle. Even though the base might be 7, we have to find the right angle that goes across. So as you see in red, I've put my little dotted line and said, all right, at a right angle there, we'll say, I don't know, I think 4 is probably too little. It's probably more like 6. Let's call it 6. Okay, so across there's 6. So now you can tell what the area of that triangle would be. Okay. Now we've got triangles going up to the vertex at the top. And as you can see, I tried to make, here let's make it a little darker. Here is my perpendicular line to the base of 7, and it's at right angles, and we're saying it's 10 units. So this, and for our purposes, we don't even care what the edge of that triangle is because it doesn't factor into the formula. The base is 7, the height is 10, and we have 3 of them, and they're identical. So, with that in mind, I want you to write it out as a formula. You have 4 different surfaces. 3 of those 4 are exactly the same. And then find the surface area for the whole thing, just like you did in the last lesson. The last practice one, it looks like it's after an earthquake, doesn't it? Because I can't draw a straight line. So here is another one. Notice that now we have a base, which is a square. So let's give it some dimensions. Let's say that that's a 5, which of course means all the other edges are 5s. But we also need the height, and we'll say that that height here is 8. So let me show you. It goes from the top here all the way down, and we're saying that's right angles from this base. There are 4 identical triangles and 1 square base. So you're going to write out a formula for that and then solve and find the surface area of this figure. And that's it. All right. Enjoy. See you tomorrow.